Okay, let's take a look at some of these specific gravity questions that you're going to be having to answer in Chapter 3 of the OTCO workbook. So this first one is pretty straightforward. There are some conversions that you do need to know that would be on your formula sheet, and honestly, you're going to know these numbers probably by heart by the time you finish this class. But the first thing we need to know is that there are 1,440 minutes in a 24-hour day. So 1,440 minutes per 24 hours. And the second thing that we need to know is that 1 gallon of water weighs 8.34 pounds. And with that information, we can solve this problem pretty easily. You see the information that we're given. We are told that we're pumping 37 gallons per minute of a liquid with a specific gravity of 1.16. So specific gravity is a way for us to compare the density of an unknown liquid, or a known liquid actually, to water. So, and the way that we do that would be like this. So 37 gallons per minute times 1,440 minutes in a day equals 53,280 gallons. Now, it wouldn't be a terrible idea to rewrite this equation like this so that you get in the habit of canceling out units of measure. So 37 gallons. Remember, gallons per minute. Per means you're going to have a division problem. So 37 gallons divided by, in this case, 1 minute times 1,440 minutes in 1 day, and our minutes cancel out, and that gives us our 53,280 gallons per day. So 53,280 gallons times, remember 1 gallon equals 8.34 pounds. And if we multiply that out, we get 444,355 pounds. And again, if I wrote this equation like this, 53,280 gallons per means divide, so gallons per day, times 8.34 pounds per gallon. Remember, per means divide. Then in this case, our gallons cancel out, and we get 444,355 pounds. And now this is where specific gravity comes in. Because this liquid is denser than water, and we've calculated how many pounds of water we've pumped, Now we multiply pounds by specific gravity, and that will help us know how many pounds per day of this unknown liquid we're pumping. So our last step is to multiply 444,355 pounds times a specific gravity of 1.16, and we get a final answer of 515,452 pounds. And a quick check, if you think about it logically, if it has a specific gravity greater than 1, because the specific gravity of water is 1, so a specific gravity greater than 1 means it's denser than water, means that it would sink, and should mean that it's heavier. So 515,452 pounds is of course heavier than the 444,355 pounds of water. So that's how we would do that problem. Problem number 2, kind of the same principle. In this case, they give us the pounds of sludge in gallons per minute, and we're trying to work back to specific gravity. So in this case, 800,000 pounds of sludge we have 60 gallons per minute. So I want to use that 60 gallons per minute times 1,440 minutes in a day to figure out how many gallons I pumped today, or for this day. So 60 times 1,440 equals 86,400 gallons. Of course, by setting this equation up this way, my minutes cancel out. So 86,400 gallons. Now I know that that's the number of gallons that I pumped. Now I'm going to determine how many pounds each gallon weighs by dividing 800,000 pounds by 86,400 gallons. So 800,000 pounds divided by 86,400 gallons tells me that each gallon weighs approximately 9.26 pounds per gallon. So now what do I do with this number? Well, if I want to determine specific gravity, and I know that 1 gallon of water equals 8.34 pounds, I can set this equation up like this. 9.26 pounds per gallon of sludge times 1 gallon of water, which equals 8.34 pounds. And of course, pounds and gallons cancel each other out. I wind up with 9.26 divided by 8.34. And if I divide that out, I get a specific gravity of 1.11. So that would be how you would set up that problem. Moving on to the next one. If 30,000 gallons of sludge with a solids concentration of 18,000 milligrams per liter contains 5,500 pounds of solids. What is the specific gravity of the sludge? Okay, in order to do this problem, this is where our pounds formula is going to come into play. Now, this formula is ubiquitous in wastewater math, and the pounds formula looks like this. It is flow. Now, this is important. Flow in million gallons, or million gallons per day. Flow in million gallons times solids concentration in milligrams per liter, otherwise known as parts per million, times 8.34 is going to give you pounds of solids. So in order to set this problem up, I need to calculate how much flow I have in million gallons. So this is going to be 30,000 gallons divided by 1 million equals 0.030 million gallons. You're going to use this formula a lot, so it's going to become second nature, but when you use it, you always have to remember it is flow in million gallons. So now I've got the flow, I've got solids concentration in milligrams per liter times 8.34. So let me work that out. 0.030 million gallons times 18,000 milligrams per liter times 8.34 equals 4,504 pounds of sludge. And that would be for, if you think about it, a liquid with a specific gravity of 1. Or a specific gravity the same as water. But what this problem is telling us, and what it should be telling us, and which hopefully is intuitive to you, is that the specific gravity of this sludge must be greater than 1, because it's sludge, because it sinks to the bottom of a tank. That's what makes it sludge. It's going to have a specific gravity, or in other words, be denser than water. So now that I have what my theoretical pounds would be with a specific gravity of 1, I can compare the two. I can compare my 5,500 pounds of solids, and that will help me determine what the specific gravity is. So 5,500 pounds divided by 4,504 pounds. Pounds cancel out, and the specific gravity basically is just a ratio. So 5,500 divided by 4,504 equals 1.22. So our specific gravity in this instance would be 1.22. And the last problem is virtually the same as the problem we just did, except that you were given the specific gravity, and now we can plug that into our pounds formula to figure out our total pounds. So remember, pounds formula, flow in million gallons, or million gallons per day, times solids concentration in milligrams per liter, times 8.34 and we're going to add one more step to it, times specific gravity. And if you're not given a specific gravity, then generally you can assume that the specific gravity is 1. In this case, we're given a specific gravity of 1.05, so we have to plug that into our formula. 38,000 gallons per day converted to million gallons. 38,000 gallons per day divided by 1 million, because we have to convert it to million gallons per day, is going to be 0.038 million gallons. And now we can plug that into our formula. 0.038 million gallons times solids concentration, 17,500 milligrams per liter, times 8.34. And then this is where our specific gravity comes into play. Specific gravity of 1.05. And let's go ahead and multiply it out. 0.038 times 17,500 times 8.34 times 1.05 gives us a total amount of 5,823 pounds. So yes, this pounds formula you're going to use a lot, especially when we get to the activated sludge part of the class. As I said, it's ubiquitous in wastewater. If you want to see where that formula is derived from, it is in the appendix in the back of the textbook, that part of the reading that you're assigned for this week. It's up to you if you want to research it further. For the purposes of this class and for the purposes of doing the kind of math that we do all the time in the industry, we don't really care where that formula came from. We just know that it works, and we use it all the time. Pounds formula, flow in million gallons times milligrams per liter times 8.34 times specific gravity, possibly if you're given a figure. So that's how to do the math on the first part of the chapter. I'll do another video on some of the other math going forward.